derivatives. We started with a reaction with the ammonia and its derivative. Before I will start proceeding, let me just write down for you that same one. Then we'll discuss the reaction because that thing should be there in mind. So daily I need to just recapitulate it. Ammonia derivative. It is ammonia, NH3 ammonia. When I will say ammonia derivative, it means that NH2 and Z. Okay, this Z means one of the H we are going to replace with the different groups. Like if I'm going to replace Z with the OH, if I'm going to replace Z with the OH, we call this one as your hydroxylamine. This we called as your hydroxylamine. This we called as hydroxylamine name. If I'm going to replace Z by NH2, we call this one as your hydrazine. Same thing we have done yesterday. This we called as name. You must keep name in mind. Hydrazine. If in hydrazine one of the hydrogen I can replace with amide group C double bond O and H2. I replaced one of the group with the amide group. Then it will become semi-carbazide. It will become semi-carbazide. It will become semi-carbazide. Okay, it is NH2 NH C double bond O NH2. It will become semi-carbazide. If this NH2OH NH2NH2, if I'm going to replace one of the hydrogen by the phenyl group, here I'm having a phenyl group. Okay, I'm going to replace with the phenyl group. The name for this one is given. Name we called as phenyl hydrazine. Name we are going to give them as phenyl hydrazine. And last one, and very important, NH. If I'm going to replace one hydrogen in the hydrazine by NO2 group, I'm going to place NO2 here and NO2 here. So it will be a 2,4 dinitrophenylhydrazine. 2,4 dinitrophenyl. One word only. I'm going to write down words. Hydrazine. 2,4 dinitrophenylhydrazine, or we call this one as DNP. DNP, dinitrophenylhydrazine. Or iska one more name is there. We call this one as your Brady's reagent. We called it as your Brady's reagent. Brady's reagent. We called it as your Brady's reagent. Okay, one more name for this one. So these are the ammonia and its derivatives. You must have the names in mind. Then we are going to discuss the reaction. So we have hydroxylamine, hydrazine, semi-carbazide, phenylhydrazine, dinitrophenylhydrazine, DNP, that we called as Brady's reagent. Now let me start. I'm going to discuss general reaction with you, how this general reaction is going to take place. So this is carbonyl compound C double bond O. It can be aldehyde, it can be ketone. It can be aldehyde, it can be ketone. And here I am having the ammonia derivative NH and Z. I hope this thing will be clear to you now. We are going to replace the Z by the different groups and we are going to get the products. So if I will replace Z by the OH hydroxylamine like this only. So after this, what I'm going to do here, nitrogen is having a lone pair of electrons. So it will undergo nucleophilic, I told you, addition reactions. Reaction will take place like this. Oxygen will shift, H will attach here. This nitrogen going to attach here. There is a formation of a adduct. I'm going to draw the adduct here. Adduct will be like OH. Here I will get the nitrogen, hydrogen and Z. From here, water molecule will move out, H2O, and we will get the product, double bond N and Z, nucleophilic addition reaction. I told you, instead of going this one, you can do in a shortcut way also. What is that shortcut? Shortcut is C double bond O. And here I'm having NH2 and Z. So from here I will remove the water molecule H2O, and when I will remove the water molecule, product I will get, it will be N and Z directly I can write down. This is a general reaction. Under this general reaction, till now, we have done the reaction with hydroxylamine, NH2OH. Product named, I told you, there is a formation of oxime. Then second one, we have done with the hydrazine. Hydrazine, product formed will be hydrazone. Then I started with semicarbazide. So I will start with the semicarbazide. Just see here. I told you this is a very, very important thing in semicarbazide. First to semicarbazide. Semicarbazide is basically we have NH2, then we have here NH, then we have C double bond O NH2. This is semicarbazide. But this is called as semicarbazide. I told you they are going nucleophilic addition reaction, and in case of semicarbazide, we are having these three nitrogens. We are having these three nitrogens. This nitrogen number 1, this is nitrogen number 2, and this is nitrogen number 3. So out of these three, which nitrogen is going to give its pair of electron, which is going to act as nucleophile? Yesterday I told you here nitrogen 2 and nitrogen 3, they are in conjugation with the C double bond O. Nitrogen 2, nitrogen 3 are in conjugation with C double bond O. So these pair of electron, they are not available for the donation. Hence, this nitrogen is in a condition to give its pair of electron. So it can give its pair of electron and make the product. So this is going to be happen. Reaction I'm going to just write down here. Let me take example of acetaldehyde. Here I'm having a acetaldehyde. Okay, just wait. Okay, acetaldehyde, and I'm going to react this acetaldehyde with the semicarbazide. Important thing, you must know how to write down the semicarbazide. Okay, this is the correct way of writing a semicarbazide. Suppose if it is going to be written like this: CHH, C double bond O, NH and NH2. Because books, maximum books, they are going to confuse you. They are going to write on a wrong way. If they are going to write on like this one, direct shortcut I am going to do. I want to remove this water molecule. Product I am going to write down. So from here, first case though I can write down, but second case is wrong. Okay, in second case I cannot do it. First I need to invert it because this nitrogen is going to participate, not this one, because this is in conjugation carbonyl group. So we have to do from this side. So product I am going to write down here. Product formed will be carbon. Here we have the H, here we have the CH3, here we have double bond nitrogen, then we have NH, then we have C double bond O and NH2. This will be the product, that is semicarbazone of acetaldehyde. It is a semicarbazone of acetaldehyde. Let me continue. Semicarbazone of acetaldehyde. Next example I will take with the acetone. Acetone, C double bond O, C double bond O. Here I am having a CH3. Here I am having a CH3. Here I will get NH2. Here I am having a NH2. Here I will get NH, C double bond O and NH2. So again, what will happen from here? I can remove a water molecule. Okay, pH I told you have to keep 4.5 yesterday. Okay, because protonation of nitrogen take place and further reaction is not going to happen. So I'm going to remove from here, and product I'm going to get. Product will be our CH3. This shortcut way I'm explaining. Okay, this shortcut direct to write down the product. C double bond O NH2. Semicarbazone of acetone. This is semicarbazone of acetone. So this is a reaction with the semicarbazide, and in semicarbazide, this part is very important as per your board exams are concerned. Now, next one we are going to do, we are done with the hydroxylamine, we are done with the hydrazine, we are done with semicarbazide. Now we are going to do with the phenylhydrazine. Okay, phenylhydrazine. Next reaction with the phenylhydrazine. So let me draw the structure first for you for the phenylhydrazine. So hydrazine is NH2, nitrogen, hydrogen, and this H1H I'm going to replace with the phenyl group. This is your phenylhydrazine. Phenylhydrazine. Easily you can check out this nitrogen, so not going to take part because in conjugation with the ring. So this nitrogen going to give its pair of electron. So let me write down here. It is C double bond O, H is here and CH is there. Acetaldehyde, and it is phenylhydrazine, nitrogen H, shortcut, water molecule, pH, I told you 4.5, maximum yield. In every reaction we have to write down. I'm going to write down here. You know that why we need to do it. Okay, protonation is going to happen and nitrogen not longer going to act as your, it's not oxygen here, it's nitrogen, then H, then hydrogen. Okay, phenylhydrazone, product name will be phenylhydrazone, phenylhydrazone of acetaldehyde. With acetone I will do C double bond O, CH3, CH3 plus NHH, NH, phenyl group, water molecule, pH 4.5, 4.5, product C, CH3, CH3, double bond nitrogen, NH, phenylhydrazone of acetone, phenylhydrazone of acetone. So this is the reaction. Last one I'm going to do now with a DNP, Brady's reagent, 2,4 dinitrophenylhydrazine. I hope now your reaction so you can do very easily, no trouble. Let me go for next one. And just keep one thing in mind, I'm not sharing link with you, but I'm making the videos public. So this video that right now we are just working on it. So you can access it from the channel, okay? You can access it from there. If you want to see it again, you can just check out from there. From the channel you can access. So let me write down for the next one. 2,4 dinitrophenylhydrazine. So hydrazine I'm knowing, NHH, NH2 hydrazine. 2,4 dinitrophenylhydrazine, matlab here I'm going to write down NO2. Here I'm going to write down NO2, 2,4 dinitrophenylhydrazine. 2,4 dinitrophenylhydrazine. So we are going to react. I hope you can do it very easily now. So I'm going to react this one with the aldehyde first. CH here, CH3, acetaldehyde here. And I'm going to react this one with the 2,4 dinitrophenylhydrazine, and we having here, H we are having here. And we are going to react it here with, here we have the NO2. Here I'm having a NO2. We are going to just remove it here. pH we are going to maintain 4.5. Water molecule, shortcut I am using. Water molecule, I am going to 5 phenylhydrazones will be formed. CH3, double bond nitrogen, single bond nitrogen, hydrogen, and here I will get the NO2 and NO2. This we called as phenylhydrazones. Phenylhydrazones. It is phenylhydrazone of acetaldehyde. Up now listen, please focus. Very important thing. Very important thing. Please listen. These all reactions with acetone also I will do. Let me do it for the acetone. Okay, just let me do it for the acetone also. C double bond O. Here we have the CH3. Here I am having a CH3 plus NH, and here I will get the NH. And here I am going to get NO2 2,4 dinitrophenylhydrazine. And here I am going to write down the pH 4.5. 3 to 5 also you can write down. Water molecule we are going to remove from here. So product I am going to get, it will be your CH3 here. CH3 double bond nitrogen, single bond nitrogen, H here. And I will get NO2 here and NO2 here. Phenylhydrazone of acetone. Phenylhydrazone of acetone. Now please listen, okay? Please be focused. Very important conclusion we are going to discuss it. So please focus. Listen to me carefully. All these reactions that we have done right now, all things that we are doing, okay, here, this one. So these all reactions are characteristic. These all reactions are characteristic reactions of aldehydes and ketones. Very important thing. When I will say characteristic, what is the meaning of this? Characteristic means these reactions are only specific to the aldehyde and ketone. ये reaction सिर्फ aldehyde और ketone दिखाएंगे. Only aldehydes and ketones going to show these reactions. Okay, nothing else. The aldehyde ketone is going to represent these reactions. They are characteristic reactions of aldehydes and ketones. Second thing, okay. We have last reaction. I will just concentrate on this one. DNP, 2,4 dinitrophenylhydrazine. This is DNP. Okay, here we have the DNP. When we are going to react this one with the DNP, there is a formation of phenylhydrazones, and these phenylhydrazones, there is a formation of PPTs, and there is a formation of PPTs, and these PPTs will be bright red color PPTs. There is a formation of bright red or yellow or orange depending upon the compound. So this product formed, they will have the bright color. They are bright colored PPTs. There's a formation of bright color PPTs, bright yellow, okay, bright red PPTs will be formed. What is the meaning of this? Bright color PPTs are formed. Bright color PPTs are formed means, suppose I will give you, in a lab you will come and I will give you some unknown organic compound. Okay, you're not knowing whether it is aldehyde, whether it is ketone, whether it is carboxylic acid, whether it is alcohol, whether it is ether. And I will tell you, okay, find out which organic compound I gave. Okay, you have to find out the organic compound that I will give you in a lab. So for every reagent, there is a reaction. Right now we are discussing DNP. In lab, DNP is present. What you're going to do, you're going to take small sample of that organic compound in a test tube, and you are going to add a few drops of DNP, dinitrophenylhydrazine, and little bit you are going to heat it. If you are going to get a bright color PPTs, that will confirm in that organic compound that you took, that organic compound can be aldehyde or ketone, matlab it can be carbonyl compounds. That's a very, very important thing. It is used for the distinction, like Lucas reagent we have done. Okay, Lucas reagent used for the distinction of primary, secondary, and tertiary alcohol. This DNP is used for the distinction of carbonyl compounds from the non-carbonyl compounds. Carbonyl compounds from the non-carbonyl compounds, because there is a formation of PPTs. It's your turn to ask questions. Please ask questions. Otherwise, I'm going to just change the next topic. I will go. Please ask questions. Yeah, please ask question. Chali, I will just continue. Okay. DNP, I hope you understood. I'm moving to next topic. Okay, they are characteristic reaction. We have done reaction with the ammonia derivative. We have to now do the reaction with the ammonia. Okay, that's important thing. Ammonia. The first two reactions we missed. Not missed. Okay, it should be done in last only. So I'm going to do the next reactions. So now we have done with the ammonia. We have done with DNP. Brady's reagent. I told you it's a very, very important. Semi-carbazide we have done. Now we are going to do the reaction with the ammonia. Okay, with ammonia we are going to do. With ammonia, it is going to react in a different way. Like we have done simple reactions. Okay, like let me write down here reactions for you. It's also very important. C double bond O, CH3 and H acetaldehyde. We are going to react this one with the ammonia, NH3. We are going to react with the ammonia. So reaction take place in the same way. Okay, that already you're knowing it. I must write down NH2 like this, N and NH2. It must be written like this, H and NH2. So density is going to shift over oxygen. This H will come here. This nitrogen is going to attack here. Like already we done. There is a formation of adduct. Let me draw adduct for you. Here I will get the CH3. Here I will get the H and OH and NH2. Okay, this is a formation of this thing. Then after that, again, water molecule we are going to remove, H from here, OH from here. By shortcut, you can do it in a first step also, no trouble at all. H I will get here double bond NH2. So this is a reaction of ammonia, but this reaction is with the acetaldehyde and ketone. But this ammonia is going to react differently. It is going to react differently with formaldehyde and benzaldehyde. Exception, so important, but this reaction is not there in NCERT, so it's okay. Ammonia going to react in a different way with the formaldehyde and benzaldehyde. With the rest, everything they are going to react in this way. Like if I'm going to react this one with the formaldehyde, okay, with formaldehyde, just see the reaction here. HCHO, formaldehyde